Hello all, good morning. Welcome to this Docker session. So till now we have seen about the containers, about the Docker images, Docker file, how to create a custom image, how to use all those instructions to create a custom image and how to build it. And once we build it, how we can push that custom image to our personal Docker Hub account that we have seen. And in the last session, we talked about the Docker volume that is mainly for the data persistence because any log files or any other file got created within the container. So those file will not be accessible if container gets deleted or inaccessible. In that case, we have to make use of the Docker volume to persist the data. So in that case, what is going to happen? The file which are going to create within the container will be will be in sync with Docker host as well. Okay, so that if there is any issue with the container or containers get deleted, still we will be having the access to those files because those files were synced with the Docker host. Now we will talk about network over here, which is very important part in the Docker to understand how communication works over here. Okay, mainly whenever you will see the word network, that time you just have to think about the communication. It's all about the communication. Like let's say if you are calling to your friend and your voice is not reachable properly to your friend, so he will say might be a network issue, right? So mainly in any aspect, if you talk about network, it's all about the communication. So similarly within the Docker as well, networking is very important because communication between two containers is important over here. Let's say this is our Docker host. A Docker host means a server where you have installed the Docker, and this is, let's say, a container C1, and this is another container C2. Okay, now how these containers will talk with each other. Okay, so this is the Docker host, let's say C1, and this is C2. Okay, so these two containers want to talk with each other because if you want to build an entire project, so entire project cannot be built with only a single container. Single container will have single application. But if you talk about, let's say, a Flipkart, okay, there are multiple applications like ordering application, then there is billing application, then there is invoice application, email application. So there are a lot many applications are present within the Flipkart. So once you place an order, then ordering application will get invoked. Once you go to the billing section, and then uh, you have to do the payment and all those things. So this can be taken care by the billing application. To generate a bill and send it over, means create that PDF format of the bill, can be done by the invoice application. And to send that generated email over the generated PDF or generated invoice over the email can be done with email. So it's not like there is only four. There can be many applications involved within the Flipkart. Same goes for other websites as well. Okay, so each and every application will be having only one container, means within a single container there can be only one applications up and running. So C1 will have, let's say, ordering, C2 will have billing, C3 will have invoice, C4 will have an email. And to form an entire application, these all containers should communicate with each other because जैसे ही order हो जाता है, so ordering will send a message to the billing that okay, this a customer have placed this order, so please go ahead and do the billing section of this particular item. Okay, so definitely ordering application will send some data to the billing application. Same goes for billing application will send data to the email invoice application to generate a PDF format of the bill, and same goes for this. So what I'm trying to say over here, to build an entire project, or to build an entire product, we will definitely need container communication with each other. So right now let's consider a simplest scenario that we have two containers, and these two containers will definitely talk with each other. Okay, so the default scenario of this container is like, or the default scenario of this Docker is like, each and every container can talk with each other. Okay, okay, so over here there are three types of network. Okay, one is like bridge network. You just need to know the name and when to use which one. Host network and none networks, and most of the time bridge network is getting used. Host and none networks are rarely used. So first of all we will talk about a bridge network. Means what is the difference between these and when to use which one. So the default communication happens between these two containers is always over the bridge network. Okay, so the communication between C1 to C2 and C2 to C1 is always going to happen over the bridge network. You can see all this information in the inspect as well. Okay, so where it is actually defined, and let me show you that particular thing. As of now, uh, do we have any container? No. Let's create a container, hyphen d hyphen name as c1 from nginx. Okay, so I have just created a container over here. Let's try to inspect this container c1, the one we just created. And now in the last section you will see networking. Okay, so it's this information about the container and about the network is available over here. So bridge is the default network that will get attached to your container. Okay, I mean, this is the default and there is no way that you can change the default network. Docker provides a bridge network as a default network, and the use case of the bridge network is that it allows container communication smoothly without any problem. Okay, means any container which is getting created within this uh, Docker host, and by default each and every container will have a bridge network associated with it. So in that case they can definitely communicate with each other without any issue. Okay, so that's what I'm trying to say. This, let's see, if I create c1 and c2, they will always going to communicate over the bridge network. Okay, so if you want to test it out whether those are able to communicate or not, so let's see. So for that matter, for communication, how you do it, you just do ping command to c, like let's say if you log into the c1 with the help of docker container execute, and if you try to check whether c2 is accessible or not, in that case from c1 you are going to hit this command like ping c2, and if you get a response back from the c2, in that case definitely it means c1 is able to communicate with c2. Same goes for c2 to c1 as well. Log into the c2 and do ping to c1. Okay, so let's check whether the ping command is available within this container or not. Okay, so for that matter let's log into the container c1. Okay, let's say ping. As of now this ping utility is not available because a container is something which is having only the required packages. The way Unix server or the like a Linux machine will have all the Unix commands up, okay, present within that. But a container is a lightweight container. That's why we call it as a lightweight container, because only the required things are present within the container, not all. That's what it makes a lightweight. So if you want to go ahead and install the ping, then let's update the package over here. Means if there is a requirement to have a ping command within our container, then definitely we can do so. So I have just provided over here ping command can be installed with the help of this package. If you are going to install this inet utils package, okay, in that case ping is going to install on your system. Okay, so now you can see ping is available. So instead of like installing this ping command within the container, uh, I'm going to create a custom image which will have ping present within that. Okay, so for that matter, let's create a dummy folder one and create a docker file. From nginx run apt update, and once this is done, run this command. So what I'm trying to do now, I'm creating a custom image over here, and that custom image should have a ping, so that I don't need to install the ping command separately within the container. So let's save it and do the create a image. Okay, so let it finish. So we have just created a image with this name, and now let's go ahead and try to create a container one more time. So before doing that, let me delete the previous container, and let's try to create a container one more time. And I will create from this, let's create one more container from the same. Okay, now we have two containers available with us, and I want to see whether those are able to communicate with each other or not. Okay, so c1 to c2 and c2 to c1 are able to communicate with each other or not. So there can be communication based on the host name and based on the I meant to say IP address as well. So we will just talk about IP address first and talk about a hostname later. I mean to say each and every container will get some IP address. Okay, so where it is written, you will get to know that IP address only by doing inspect to the container. Okay, once you do inspect to the container, you will see IP address over here. So C1 IP address is this one. So let me write it down over here, and let's inspect C2. C2 IP address is this one. Okay, now let's log into the C1 and check whether those are able to communicate or not. Where is that execute command? Okay, I have logged into the C1, and let's log in. This is the IP address of the C2. Okay, now you can see you are getting response back. It means there are 4 packets transmitted from C1 to C2 and 4 packets received by the C2 and 0% packet loss. It means the communication between the container C1 and C2 is okay. There is no issue in the communication. Similarly, let's try it out for the opposite, like C2 to C1. So for that matter, let's log in to the C2 and ping to the C1. C1 ka IP address is I think it's just end with 2. Let me double check. Yeah, 172.17.02, the same thing. And now you can see the communication from C2 to C1 is also okay over here. I'll do Control C, and same goes here as well. There is 0% packet loss. It means there is no issue in the communication. Why there is no issue in the communication, why they are able to successfully communicate with each other, it's just because they are connected with each other over the same network, that is nothing but a bridge network. If you just do inspect to C1, you will see bridge network over here. Same goes to C2, you will see bridge network over here. So by default, any container you create, that will get mapped to the bridge network. So as we are using a single network for all the containers, so that's why they are able to communicate with each other. But here is one catch. uh, uh, the IP address of the, I won't be able, means I have just done the connection or the communication over the IP address. But what if I want to do communication over the direct container name, like I want to access C2 from C1? So now you can see ping unknown host. So you will get to see this kind of error, like communication over the IP address is possible over here, but communication over the container name is not possible right now. So this is a limitation of the bridge net default bridge network. Okay, this is the limitation of default bridge network, but this can be overcome by creating a custom bridge network. You can create as many custom bridge network as you want. And why do we need so? Okay, first of all we will talk in that language, and then I'll show you how to create that. Okay, so let's talk about the scenario first. Now let's consider that this is a project I'm handling, let's say a Flipkart project, and this is the Amazon project, let's consider. Okay, this is the Flipkart and this is the Amazon project. Okay, and definitely I'm going to create a billing, then invoice, ordering, front end, back end, lot many containers as part of this Flipkart project. Same goes for Amazon as well. Okay, I'm going to create lot many containers over here. And if each and every container is using the bridge network, then these two containers can also talk with each other, because each and every container is using the same network. But as of now you don't see any need to communicate a Flipkart container and Amazon container, because these two are the different products that we are building. So there is no need to there is no need of communication of this first container and second container over here. So this communication should be avoided, or this communication should be dropped. So for that matter we have to create a custom network, because by default each and every container will have a bridge network and they will be able to do the communication. But if you want to avoid such a problem, in that case custom network is the only solution that we have to follow. So how we can do that? First of all we have to create a custom network, let's say Flipkart network, and create one more network like Amazon network. And whenever you are trying to create a container, in that case just provide the network name. Okay, let's say if you are trying to create this container, in that case while creating a container only just provide the network name in which you want to create. So while creating it, provide this network name, and same goes for this. While creating this network, so while creating this container, provide this network name, so that my container will know that it belongs to which network. Okay, and what is the benefit of this? Once you do so, this communication will not be possible if you do so. Okay, so let's try with practical, then definitely you will get to know the solution about it. So what I'm going to do over here, let me delete all the containers. And how many networks we have as of now? As of now there are three networks. These are the default network provided. Means if you install Docker at your end and try to look for the Docker network ls, you will get to see the same solution, like the same output, that you will have a bridge network, host network, none network. And over here we are talking about the bridge network, because this is the default network which gets associated with your container. Now let's create one more network over here. Let's say Flipkart one and Amazon one. Okay, we have just created two networks, and the type of the network is nothing but a bridge network. Means a driver bridge is nothing but this is the type of the network. So this will allow the communication. So I have created one Amazon, I have created another as a Flipkart network. And while creating a container, okay, let's say if I create a container, okay, let's say I'm going to create a container C1, and if I don't define any network, then this is the bridge network which will get associated. But I want a Flipkart network to be associated over here, so let's provide a network value hyphen network equal to this network. Same goes for, let's say I'm going to create wait, just to avoid communication, I'm in the control C, and let me remove this container, and these two extra networks I have created. And let's me create a container with, let's say, F1 for the Flipkart one, and F2 for the Flipkart. And let's go ahead create A1 for Amazon and A2 for second Amazon. Okay, so what I have done, I have created a F1 and F2 container which belongs to network Flipkart, A1 and A2 container which belongs to network Amazon. Okay, let's log into the F1 then. If you try to do ping, now F1 and F2 belong to the Flipkart, A1, A2 belong to Amazon. So now I logged into the F1. So if I say ping to F2, then you can see I'm getting packets, there is 0% packet loss over here. So from F1 to F2 communication is successful because those belongs to the same network over here. If I try to ping to A1, then you will see a message like unknown host. If I try to ping to A2, you will see the same message, because this A1 and A2 belongs to some other network. F1 and F2 belongs to some other network. So the problem which I was facing earlier, that each and every container was having access to each other, that problem I have just resolved it, because I don't want my Flipkart container to access the Amazon container. And the way of handling this problem is nothing but create a custom bridge network, and while creating Flipkart container, assign a Flipkart network, and while creating an Amazon container, assign a Amazon network over here. So this way we can definitely resolve the problem. Same goes for this as well. Let's say if you log into A1, okay, and once you log into A1, then if you do ping to A2, the things will be working fine. But if you try to ping to F1 and F2, you will not see any output over here. Okay, but this was the important part of our bridge network. Okay, because we just need to know uh, the limitations of the default bridge network. The default bridge network was not supporting a hostname based access. I mean to say, like directly ping A1, ping A2. This kind of commands were not working fine over the default bridge network. Default bridge network works only with the IP address communication, not over the container name communication. Okay, and if you want to So this is the limitation of the default bridge, but if you create a custom bridge network, then definitely you will directly go ahead and do ping to container name directly without providing the IP address or without getting to know the IP address of that. That is the main benefit of this. Why like we are not using IP address and directly using the container name? Because right now if I do ping A2 and let's say it is working fine, and if there is any issue with A2, I can directly go ahead and if that A2 gets deleted, then I can directly go ahead and create one more container with the same name A2, and again it will start working. But if I make use of the IP address over here, then in that case, whenever a container gets created or recreated, the IP address will change. Okay, there is no guarantee like अभी A2 को IP address मिला है 1.1.1.1, so there is no guarantee कि आगे भी जब मैं A2 बनाऊंगा तो I will get the same IP address. So there is no guarantee. The IP address may change on the fly. Okay, so that's why like a tracking a container with IP address is something not good, because IP address may change when a container gets recreated. Okay, so let's talk about other networks little bit over here. That is nothing but a host network. If you see Docker network ls, so for that matter, let me delete the containers which I have created earlier. C1, I think, which all containers? Okay, A1, A2, F1, F2. And which all networks I have. So I have this Amazon network, Flipkart network. Okay, and if you want to delete this, just you can do Amazon network prune, so which is going to delete the networks which are not in use. So as of now, I have deleted a containers of Amazon network and deleted containers of Flipkart network. So those networks are not in use for me, so that's why it has deleted these two networks automatically for me. If there is a container up and running which is using the Amazon network, then this network will not get deleted by a prune. Prune is a command which is to delete unwanted things. Unwanted things like volume, containers, images, networks. So those kind of unwanted things can be deleted with a prune directly without mentioning the name. It will identify which all networks are unused, and it is going to delete all those networks. Now let's move towards another kind of network, that is nothing but a host network over here. Okay, let me open this meanwhile, and let's consider that this is our Docker host, and this Docker host is nothing but what is the IP address of this Docker host. Let me figure it out from DigitalOcean. DigitalOcean, just a moment. Okay, so let me log into this. Just to check the IP address which I had created, and within this learning Linux is the one, and this is the IP address I'm using. Okay, this is the IP address of the server which you are using. Now earlier what we were doing, we were just creating a container within the Docker host like this, and it was up and running over the bridge network that we have just saw. Now if you try to let's say this is the okay, and then let's say this is the nginx container, then let's say it is the name C1, and it is running over the port 80 because nginx always works over the port 80. And now if you want to access to this container from the browser, in that case what we have to do, we have to do the port mapping. And once we do the port mapping with the command like this, docker, I'll say docker container as dc docker container run -d and -p, let's say 90:80, and the image name as nginx. Okay, so like this we have to do. And once we create a container uh, with this port mapping, 90 belongs to the docker host, 80 belongs to the container, then we just have to access this url http. Okay, and once you access this url over the port 90, then definitely internally request will go to this container, and the content of this index.html file will be visible over the browser. This is the usual process that we used to follow till now. But what if you want to avoid this port mapping? Okay, this -p 9080 and all those things, if you want to avoid that, in that case directly as well you can go ahead and create a container which is going to attach to the host. I mean to say, whenever you are going to container with a host network, that container will get attached to this host. It is not going to create within the docker host. What does that mean? It means, let's say if this container, okay, this is a container, okay, if this container is going to make use of the port 80, so the port 80 of the container will be occupied, okay, and similarly port 80 of this docker host will also be occupied. That is the main difference. Earlier, if you normally create a container, then only the port 80 of the container was getting occupied. But with the host network, okay, just by making use of hyphen network host, we are attaching a container to the host server, and by doing that, the IP I mean the port mapping funda we don't have to follow. Directly we can go ahead and access this host over the port, access this container over the port 80. Let me show you practically, then definitely things will be much more clear. Okay, so let's create a container without any network, let's say. Okay, so I have created a container c1, and within the c1 like from this custom image. Okay, now we know the port 80 is being used within the container. Okay, then you should don't but only the container port 80 is getting occupied, not the port 80 over this server. If you want to check netstat-anp, netstat is a command to check the port status, whether it is free or whether it is in the listen mode, misused by any process. So as of now netstat is not installed over here, so let's install netstat with a certain command with this apt install net-tools. So nettools is a command, hit enter 2-3 times, and that is going to install the netstat for us. I don't want this 880. I'm just interested in only the port 80. So as of now you can see this is the time wait, which we can ignore if anything is into the listen mode. Listen mode means this like listening or something like listen. So those uh, arguments or those output you can see right now, it means this port 88021 is in use. 88021 is in use, then this is in use. So if anything you can see in the listen mode, it means that port is being used by a particular process. Okay, so over here the port 53 is being used by this process ID. This is the process ID, and this is the port. 53 is the port, 88021 is the process ID, and this is the process name system resolve. Now, in our case, port 80 is not in listen mode, okay? Because the port 80 is and inside the container, not over the Docker host. But what if you create a container C2 with network as host and check for the port 80. Now you can see port 80 is into the listen mode. Earlier it was not into the listen mode. I am talking about the Docker host, means this server where we are creating a container. Now what happens, this container C2 is using the network host. That's why whatever the port which was up and running within the container, it's also get occupied over the host network or over the Docker host, you can consider. That's why this port 80 is in now listen mode. If I delete this container C2, then definitely this port 80 will again go out of the listen mode. Let me show you. Now you can see I'm not getting output for this command. Let's start again. If I create a container C2 and check for the output, again it is in the listen mode. So that is the thing I'm trying to explain over here, that if a port 80 is being used by this container, so this port 80 will also get occupied over the host network if you make use of the if you make use of the host network in this case. So what is the benefit of using the host network? That is, you don't have to follow the port mapping directly. You can now, the port 80 of this host network is now mapped to the port 80 of this container directly. There is the internal mapping is already done, so you directly have to make use of this IP address colon 80 to access this container. So let's try to access this container over the network. So that is the this is the IP address colon 80, sorry, not 90, over here 80. Now you can see welcome to Nginx page. I'm getting properly over here. From which container we are getting this? We are getting the output from the container C2, not from the C1, okay? Because C1 is like a over the bridge network, and we don't have, means we haven't done the port mapping to that container having the bridge network. And in case of the host network, there is no need to do the port mapping, because the port of the container and port of the host name will all automatically get mapped to each other. So that is the main fundamental of it. Okay, so this is the thing about the host network. Just one more thing, or I can say one drawback of this host network is, like, let's say if I try to create one more container as C3 from the same network, host network. So what is the output, or how many containers you can see over here? So I can see this C3 container which I have just created 5 seconds before is into the exited status. Not the earlier container C2 was up and running, but now this C3 container is into the exited status. Any idea why it got into the exited one? Okay, let's say if you are not sure why it got into the exited status, you just can check the logs why it's into the exited one, logs C3. And now in the C3 you will see, in the logging section of the C3 you will see port 80. This is the port 80, address already in use. Okay, if the port, any port is already in use, then it cannot be taken or it cannot be consumed by any other process. Let me explain with this diagram. Now we have created a container C2 over here. Okay, this is the C2, and this C2 is making use of the port 80, and now the port 80 of the host server as well is also busy. If I try to create one more container over here with a name as, let's say, C3, and it's also using the hyphen hyphen network equal to host. So this is also going to make use of the port 80, right? So the port 80 of the container C3 will also make use of the port 80 of the Docker host, because those will be in sync. But C2 ने ही port 80 already ले लिया है Docker host का. So the port 80 is into the listen mode now. So whichever port is into the listen mode cannot be consumed by any other process or any other container. Okay, so that's why जब अपन C3 बना रहे थे, so C3 को port 80 मिला नहीं docker host का, and because of that it is into the exited status. So same is mentioned over here, the address is already in use, matlab this process is making use of the port 80, and that port 80 is already in use by other containers. So that's where the C3 is not into the up and running condition. Understood now? Okay, the last part, that is nothing but with last part of this networking section. Okay, that is nothing but the non-network. Okay, so non-network is something very private and it's rarely used. There is no such use case as well. Okay, so let's say if you create a container, let's say a C1 over here with hyphen hyphen network equal to none. In that case, this C1 will be a much secure container, much private container, and much isolated container, I can say, because this container won't be able to access from anyone else. Let's say if we have C1 and we have C2, and this C2 got created with a bridge network, let's say. Okay, C2 with bridge networks. So all the containers over the bridge network, they will be able to communicate with each other. But a container C1 which got created with a none network is not accessible from anywhere else. That is the problem over here. So if you want to keep any container isolated, if you want to keep a, if you want to stop this communication, मतलब इस C2 से C1 communication, or C4 C5 से C1, मतलब C1 से the communication towards C1 and communication from C1, if you want to stop that, if you want to block that, if you want to keep your container very much private, if you want to keep your container secure, in that case only you have to make use of the non network. So how these things will work over here? This thing will work because whenever you will create a container with non network, that container will not get any IP address, और कोई IP address मिला ही नहीं कोई container को, तो communication तो होगा ही नहीं. Okay, so let me show you in practically. Docker network ls, last you will see the non network which is having the null as a breach, and let's try to show you which container we have. So if I show you inspect to any container C1, C1 is based on the bridge network over here. Okay, so this having the IP address. Okay, C2 का मैं देखता हूँ तो C2 को भी IP address है. Okay, host network बनाया था इसलिए इसको नहीं है, because it will take the IP address of the I mean to say it will take the IP address of the Docker host. So that's why इसको खुद का एड्रेस IP address नहीं है, because it is attached to the host network, so it will take the IP address of the host, it will take the port of the host, so everything it is going to take from this from the Docker host only. So that's why this host network को भी खुद का कुछ नहीं है. But if you talk about none network, over here you can see host network. If you talk about a none network, that will also not have a IP address, but that will not even accessible from outside. If you do anything, still that container will be much secure and isolated. So let's try to create a container with none network. I'll name it as my none container. So this none container got created over here, and if you just inspect to this none network, you will see we are using the network as none, and over here IP address equal to nothing, gateway equal to nothing. You will see it means uh, there is no way by which we can access to this none network, and from none network as well the request will not go outside. So there is no much practical use case of this none network because it's very rarely used. Even in our project, in our company, we are not making use of this none network anywhere. We are simply making use of the bridge one. So those are the networking fundamentals you just need to understand to get familiarized with this Docker networks. So mainly we have seen the three types of the network. Those are nothing but first is the bridge network that we have seen in much great detail. Second is like a host network, and third is like none network. There are other network as well, but right now those other networks of the Docker we will learn in the Kubernetes, because right now let's keep it at very basic level. I will talk about other one or two Docker networking things in the Kubernetes section whenever we will see some distributed system. So for now, just understand this much, and that will be sufficient in case of the Docker. All the commands related to this container, all the commands related to this installation of the packages is already shared over the GitHub page. I'll share this link one more time over the WhatsApp. So how to create a container with a host network, a bridge network. So each and every information or the command that we are trying to use is already shared over here. So, or if you want to like make of your notes, then while repeating the recording, that time as well you can create your own notes if you think so. Okay, that's all from mine regarding this Docker network for now. If you have any doubt, we can discuss definitely. Okay, that's all from mine for today. And this was all about the networking thing. Thank you so much for joining. See you tomorrow. Take care. Bye bye.